All right, so here's section 4, is it 4.4 or 4.5? Section 4.4, part 2. We've already had part 1. Alrighty, so here we go. So again, we have to eliminate the same variable twice. Now, here's something that you can look at here. If you look at the second equation, do you see where the y has already been eliminated? You don't have a y. So does it make sense to you that I could just find a second equation with just an x and a z, which means I'm going to take these two equations and eliminate the y. If I take these two equations and eliminate the y, I'll have two equations that have just an x and a z, which is where I'm trying to go. So if I call these equations A, B, and C, and again, B, I'm just going to rewrite it as already 5x plus z equals 0. I'm going to use A and C to eliminate the y. So if I'm going to eliminate the y here, I'm going to have to multiply A by 3. So if I multiply A by 3, I'm going to get 3x minus 3y plus 12z is equal to 9. And I'm going to add that to equation C, which is simply x plus 3y plus z equals negative 9. Adding those together, I get 4x plus 13z is equal to 9 plus negative 9 is 0. So look, I now have my two equations with my same two variables, so I'm going to rewrite them up here. All right, so now it's time to eliminate either the x or the z. I think I'm going to eliminate the z by multiplying this top equation by negative 13. So that's going to be negative 65x minus 13z equals 0. If I add these together, I'm going to get negative 51x equals 0, so x equals 0. That's okay. One of your values can be a 0, just like it could be in two equations, two variables. So now we just have to go up and plug in all, going back up the equation. So like, for example, I could go and I can now plug that into here. So that would be 5 times 0 plus z equals 0. Well, z is going to equal 0 too. That's okay. Now what do I have left to find? I have left to find a y. I'm going to go and I'm going to plug it into this bottom equation to help me find y. So 0, that's x, plus 3y plus 0 equals negative 9. So 3y equals negative 9. My y is negative 3. So those three planes, even though we got some zeros, which was kind of interesting, will intersect in the point 0, negative 3, 0. And there you go. All right, these things are going to take you some practice, so make sure that you practice a lot with these. And my suggestion would be to go slowly. Really be careful so you're not making silly mistakes, because it's a lot of work to then get down into the bottom and realize, oh my goodness, I made a stupid mistake. So just go slowly the first time. So as I look at my last system here, I notice I have fractions here. I don't want the fractions. So I'm going to go ahead and I'm going to multiply everything through in here by 2, which is going to give me x minus 5y minus 2z is equal to 6. And then I still have x minus 5y, minus 2z is equal to 6. And negative 2x plus 10y plus 4z is equal to negative 12. Well, hold it a minute. Do you see what just happened? When I multiplied this bottom one by 2, I got this, and this was already the top equations. Look, these two are the exact same plane. So now my question is, let's look at this one. Is this the same plane as this one? Well, what if I were to take this whole equation and divide it by -2? I would get x minus 5y minus 2z equals 6. Holy mackerel. All three of those are the exact same plane. All three of them. So here's how we're going to write that solution. Because basically what the solution is the solution is all points that lie on the plane. Here's how we're going to write it. It's going to be the set of all points x, comma y, comma z, such that they lie on that plane. So x minus 5y minus 2z equals 6. That is going to be our solution, which basically means the solution is all points that look like this that fit into this equation. And there's the end of 4.4. Now it's time for story problems.